Last but not least for this chapter is transformations of functions. And we are going to figure out how you can take functions, and we're going to try to figure out how you can do different things to those functions. Let me show you, for example, with my son. Let's see if I can find my son picture. Where's my son? Oh, don't have it. Let's do this. Let's imagine this is my son here. This lady. This teacher lady. And we want to transform this lady. There's different things you can do in a transformation. You can move her left and right. Right? That's one type of transformation. It's a horizontal transformation. There's another type of transformation that's moving her up and down. That's another type of transformation. You have a type of transformation that makes them bigger and makes them smaller and then bigger again. There's transformations that actually rotate them. There's special transformations that can rotate them. And there's even transformations, check this one out, that can flip them left and right, or that can flip them upside down. Let's see, can I find that one? Where's the flip? Flip upside down. And we're going to talk about those transformations today, but we're going to talk about them with really specific. Why do you think I have Joe Mauer up here? Sorry, random thought. Okay, so the first one we're going to talk about is how can you move around a quadratic formula, or quadratic like this. And quadratics have a parent function. I'll show you the parent function. It's really basic. Y equals x squared. How can you move this sucker up? How can you move it down? How can you down, right and left? How can you flip it upside down or flip it horizontally around? So what we're going to be dealing with is something called a vertex form of a quadratic. And here's the vertex form. And in this vertex form, there's three main things that you got to keep your eyes open for. This A, the H, and the K. They all do something. And they do something with this. Up and down, left and right, and spread it, and crush it, and flip it, and all those things. So, what I have here, check this out. I made this. I think you'll be proud. I put together this function right here. That is the vertex form for a quadratic. Now, here in red, let's make this a cooler picture, projector mode. In red is just my parent function, okay? Y equals x squared. And we're going to try to figure out how you can make this x squared go up and down, left and right, and stretch it and crush it and everything. That's going to be my blue function. And I just have these little things that can move them around, left and right. And so first we got to ask, let's see what the k does. And I'm moving my k left and right, so I'm making a positive. Here's 8, and here's negative. And what do you guys see is happening? Well, what I see is, as k becomes positive, the function goes up. And as k becomes negative, the function goes down. So let's put that in our notes right here. For A. No, for k. We're doing k first, right? Looks like, what does k do? Well, if k is positive, it translates up. And if k is negative, it translates down. And if you don't like the word translates, you can say shifts down or pushes down or whatever, but it's the word that we're using is translates down. So probably just put it there and maybe put another word next to it so you know what that really means, okay? So this looks like what the k does. Let's take a look at what the h. What will this h do in this function right here? The thing inside the parentheses. Well, I'm moving it right. Oh, look at that. Let's get this back up to the starting point. Let's get it up there and see. Move right and left. So it looks like this h moves it left and right. And when it's positive, it's moving to the left, which is kind of peculiar. I would have thought it would move it to the right. And when it's negative, it moves it to the left. Okay, so let's go back and make note of that. So we got an h right here, and the h is negative. I don't know why it's a -1. When h is just negative, it translates right. And if h is positive, it translates left, or shifts left. So put that down in there. That's the kind of tricky one, because it's opposite what you think. If it was negative, it would go left, but really when it's negative, it translates right. Okay. And now let's figure out what that a does. This a right here. Let's figure out what this does. So we'll go back to that graph, and we'll get this kind of set up so they're right on top of each other. And we'll start moving this a around right here. see how that affects it. So right now I have a at 1, so they're the same graphs, and now I'm making it bigger than 1. Oh, it's getting really skinny. Huh. And then I'm making it now less. Oh, holy cow. So at 0, it's just like flat. Check that out. Flat line now. And then less than 0, it's now in the negatives, it's upside down and getting skinnier and skinnier and skinnier and skinnier and then skinnier some more. But at 0, boop, it's flat. Weird. I wonder why that is. I wonder what's going on when that's 0. Okay, so let's try to put this all together. A seems to stretch it. So as A gets bigger, it's stretching it vertically. And when A goes to negatives, it flips it upside down. The negative looks like it's upside down, and as it gets bigger, it stretches vertically. So let's list these ideas off in our notes. So here's what I have for A. If A is negative, it reflects. It will reflect over the x-axis. Okay, that's the technical term. When it becomes negative, remember how it popped upside down, so it's reflecting over the x-axis. If A is greater than 1, there's going to be a vertical stretch when it's greater than 1. And when A is less than 1, there's a vertical compression. It's actually fatter. It kind of pushes. I guess we really didn't talk about that when we saw this, but let's take a look at it. When A is less than 1, so let's go look at, see how it's kind of compressed down a little bit? There's a vertical compression. It's like it's getting crushed down and flattened out. You could think of it as a horizontal stretch too, but let's talk about it as a vertical compression right there as it gets crushed down. So that is what the A does for this one. Let's find this back. We're going back to our notes. So those are the 3 things that you can do to change this function around. You can change this A around and stretch it vertically or compress it vertically, or even flip it upside down. You can change this H around, and then that changes it from moving left and right. And the K is up and down. That will affect it going up and down. Just remember, with the H, when it's negative, it goes to the right. When it's positive, it goes to the left. Now on this next page, we're going to do the same thing, but we're going to figure out how the A, the H, and the K affect an absolute value function. And then we're going to move down, and we're going to figure out how the A, the H, and the K affect a square root function.